Hello everyone. In this video, we are going to cover the topic midpoint theorem under the chapter quadrilateral. Okay, so as in the starting of this chapter, we have introduced you that before quadrilateral, if we have our concepts of triangle are clear, then it's very easy for us to understand this chapter. Okay, so in this part of the chapter quadrilateral, our main topic of this will be oriented to triangle, okay, and some properties of parallelogram. So if you have revised all these things, properties of parallelogram and the some properties of triangle like congruency, then these two theorems which we have to study will be very easy for you. Okay, so there are the statement. I will explain both of them. After that, we will do proof. So now let's start. First of all, in the theorem 1, it's written that the line segment joining the midpoints of two sides of a triangle is parallel to the third side, which means suppose we have any triangle and maybe this is the triangle ABC. Then according to this theorem, if we have the midpoints of two sides, suppose for AB we have midpoint P and for AC we have Q. Here midpoint means this point divides line segment into two equal parts, which means AP is equal to PB and AQ is equal to QC. So according to this theorem, if we have in a triangle such that P and Q are midpoints of these two sides, and if we join PQ, okay, then according to this theorem, we have PQ is equal to parallel with BC. Okay, that's the statement of the theorem. I am repeating again. The line segment joining the midpoints of two sides of a triangle, which means PQ, is parallel to the third side, which means BC. Okay, so we can we can also prove this thing. So now look into the triangle ABC. These are the given things. Okay, these are given things, and we have to prove that PQ is parallel to BC. Now our proof will start from a construction in which we have to make a line there from C which is parallel to AB. Okay, so from point C, draw a line parallel with AB. Okay, and after that, extend PQ to intersect the line at point D. Okay, now after that, we will extend this and suppose this point is D. So the question is that why we have done this construction. Okay, now before going forward, now look into this figure BCDQ. What it seems like, it's similar to parallelogram. Okay, and if we prove that this figure is the parallelogram, then we can say whole PD is parallel to BC and later on PQ is parallel to BC. Now our main task is to prove that this is a parallelogram. If we do that, then we can do that PQ is parallel to BC. Now, if we have to prove this thing, what we should have that one pair of opposite lines should be equal and they are parallel to each other. If we can do such things, then it's very easy for us. So for that thing, we can consider the triangle AQP and CQB. Why? Because if these two triangles are congruent, then from CPCT we can construct some new things which we will help us to prove that this figure is parallelogram. Okay, theoretically it seems very large, so let me solve this thing. Now look into the triangle AQP and triangle CQD. So as Q is the midpoint, this one, as Q is the midpoint of AC, so we have AQ is equal to QC. It's given in the question. Okay, and one thing we have after that, that these are the vertically opposite angles. Okay, so we can say angle AQP will be is equal to angle CQD. Okay, now what is our construction? Our construction is like that we have extended the line CD such that CD is parallel to AB. Okay, we have one more thing according to construction, that CD is parallel to AB. Now I am giving you a hint that corresponding angles and alternate interior exterior angles are equal when parallel lines are cut by the transversal. So now look into this figure. These are two parallel lines and this is the transversal. So this angle will be is equal to this angle. Why? Because they are alternate interior angles. Okay. Now we can write angle PAQ will be is equal to angle DCQ because they are alternate interior angles. Okay. So now using the property angle side angle, by using angle side angle criteria, we can say triangle AQP is congruent to triangle CQD. Okay, so up to now we have only this thing that these two triangles are congruent. Okay, now our next task is to find the such conditions which will help us to prove that this is the parallelogram. Okay, if we prove these two sides are equal, then it's very easy for us to prove this thing. Okay, now what we can do by CPCT, can I say PQ is equal to QD, as these are the corresponding sides of this triangle. And one more thing, I can say CD is equal to AP because they are also alternating sides, okay, corresponding parts of congruent triangle. We can also say AP is equal to CD. Now from the equation itself, which is given in the question, what is AP? AP is equal to PB. We have written this already. So there instead of AP, can I write PB? So I can say PB is equal to CD. Okay, now look into this figure. We have PB is equal to CD. Okay, so we can say PB is equal to CD. Now, if we prove that one thing that it should be parallel, we know, or we can show it is equal. Okay, so this will be parallelogram. Now it's already proved because one pair of opposite side is equal and parallel. So we can say the given figure is parallelogram. Now we can directly say PBCD is parallelogram. Why? Because one pair of opposite sides are parallel and equal. And we have done this property in this chapter and before, that if in a quadrilateral we have one pair of opposite sides are equal and parallel, then this figure is parallelogram. Now we know this thing. So according to properties of parallelogram, we can say opposite sides are parallel. Now I can say PD will be parallel to BC because they are opposite sides of the given parallelogram. Now PQ is also a part of PD, so we can directly say after that that PQ will be parallel to BC, and that's the thing we have to prove. Okay, this is the thing we have to prove. So let me revise what we have done in this question. First of all, we have given P and Q are the midpoints of the given sides AB and AC. And we have to prove PQ is parallel to BC. So to prove such thing, we have started our proof with construction CD parallel to AB and extend PQ to mid D. Now, what we have proved after that, and triangle PQA and CQD are congruent. And using CPCT, we have proved like these sides are equal and they are parallel according to our construction. So if in a quadrilateral, one pair of opposite sides are equal and parallel, then we can say it's a parallelogram. Now using property of parallelogram, what we have, opposite sides are parallel and equal. So we implemented this property with these two sides, PD and BC. So later on we get PQ is parallel to BC, which is there. Okay, so that's the property or theorem 1. Now after that we have one theorem also. We can say this is the reverse or converse of the theorem 1. So what is there? The line drawn through the midpoint of one side of a triangle. Okay, so what we have, let me write all the things. So now in this triangle, suppose this triangle is A, B and C. So in a triangle ABC, the midpoint of one side of a triangle, suppose midpoint of AB is P. Okay, suppose its midpoint is P. Parallel to another side, which means it's given to us that this line is parallel to BC. Okay, it's given to us. So we have to prove that it bisects the third side. Suppose this is intersecting at Q, then we have to prove AQ is equal to QC. So let me explain the theorem 2 again. A line drawn through the midpoint of one side of a triangle. Okay, P is the midpoint of AB. Parallel to another side, PQ is parallel to BC, it's given. And we have to prove it's bisect the third side, which means AQ is equal to QC. We have to prove this thing. Now, let me write the given things which we have. It will help us to prove. First of all, we have AP is equal to PB. And then we have PQ is parallel to BC. These are the two things which we have. Now I am starting my proof, and in that case also our proof will start from a construction that draw a line from C parallel to AB. So it will look like that. Okay, and after that extend PQ to intersect the drawn line at the point D, which means we have to extend this, and this line is point is D. Okay, now what we have to do, if we prove the congruency of this triangle like APQ and triangle CQD, then we can directly say by CPCT these two sides are equal or we are done. Okay, so for that, now look into the quadrilateral PBCD. Okay, this quadrilateral PB and CD. So in this quadrilateral, what we have? Okay, we have PB is parallel to CD. Okay, from construction, we have constructed this side CD as it's parallel to this one. Now, one thing we can say, PD is parallel to BC. because it's given in the question that PQ is parallel to BC and PD is nothing but just the extended version of PQ. So this one is parallel also. Now, if in any quadrilateral we have that one pair or both opposite pair, okay, both pair of opposite sides are parallel, then we can say the given quadrilateral is parallelogram. Okay, it's the property. So we can say PBCD is parallelogram. Okay, now look into the quadrilateral PBCD. Okay, as PD is parallel to BC and AQ is the transversal. Okay, or we can say if these two lines are parallel, AB and CD, and AC is the transversal, then this angle will be is equal to this angle. Is it clear? And in quadrilateral, as opposite sides are equal, so I can say PB is equal to CD also. One more thing, these two angles are vertically opposite angles, so they should be also equal. So now we can see, according to the congruence of angle side, we can say these two triangles are congruent. Okay, so let me write this thing. Okay, now I am proving the congruency there in triangle APQ and triangle CDQ. We have PQ is equal to, no, not PQ, we have angle PAQ is equal to angle DCQ. Okay, the one thing we have, as they are cutted by the transversal, I have explained already. Now angle PQA is equal to angle CQD, this angle PQA and CQD. Now look there, what we have given AP is equal to PB. Okay, there. And according to properties of parallelogram, we have CD is equal to PB. Now, if we equate these two things, what we will have? We have AP is equal to PB is equal to CD. Or we can write we have AP is equal to CD. Okay, so I am writing that thing there. We have AP is equal to CD. Now, in these two triangles, these sides are equal, angle is equal. So according to the criteria of angle side, now by angle side, triangle APQ is congruent to triangle CDQ. So we can say by CPCT, by congruent corresponding part of congruent triangle, these two sides AQ will be is equal to QC. By CPCT, AQ is equal to QC, which means Q is the midpoint of AC. And we have to prove that thing. We are done now. AQ is equal to QC. We have to prove and we are done. So that's the method by which we can prove the theorem number 2. Now we have a question there. We have to complete this one by using the above property. So what we have? ABCD is given a rhombus. So first of all, let me draw a rhombus. Okay, so ABCD is a rhombus. After that, PQRS are the midpoints of the side AB, BC, CD, and DA. For AB, we have a midpoint P, and for BC, we have a Q, and for CD, we have R, and for DA, we have a S. So we have to show that the given quadrilateral is the rectangle, which means PQRS. If we join this, so we have to prove in this question that PQRS is rectangle. So for rectangle, we have to prove that any of the angle is 90 degree and it's parallelogram. Okay, if we prove that PQR is a parallelogram and any one angle is 90 degree, then it's the rectangle. Now our proof starts there. First of all, join BD. We have to join BD, this one, and join AC also. Join AC also. Let me use different color for them. It will be easy. Okay, diagonals I have drawn from the red color. Now, as according to the properties of rhombus, okay, as according to properties of rhombus, diagonals of rhombus are perpendicular bisector of each other. So we can say that this angle is equal to 90 degree and these sides are equal and these are equal. Suppose this point is O. Okay, so why we have done this construction? Because using this we have to prove that this angle is equal to 90 degree. Okay, if we are able to do that, then it's very easy for us. Now look into triangle. In triangle ABC, okay, this one ADC, can we say as S and R midpoints of AB and DC, S is midpoints of AD and R is midpoints of DC. Now using theorem 1, can I say the line segment joining the midpoints of two sides of a triangle is parallel to third side? So in triangle ADC, using theorem 1, I can directly say SR is parallel to PQ. Okay. Now in triangle ABC, now in triangle ABC, we can say using theorem 1 again, using theorem 1, PQ is parallel to AC. But I written SR is no, there is not with PQ. It's AC. We are considering in the triangle. Now suppose this one is equation 1 and this one is equation 2. Now using equation 1 and 2, can I say as a line parallel to the third line, we can say then all three are parallel, which means if L is parallel to M and N is parallel to M, then we can say all three are parallel, which means L is parallel to M and M is parallel to N. So from 1 and 2, we can say SR is parallel to AC, it is parallel to PQ. Now, what I can write, SR is parallel to PQ. Okay, this side, SR is parallel to PQ. Now I can mark it as equation number 3. So can similarly, if I construct these triangles, as the property will also same hold and both are rhombus. So using this, I can directly write similarly SP parallel to RQ. Okay, so if we use these two properties, it's in the parallelogram or quadrilateral PQRS, both pair of opposite sides are equal. So I can write PQRS is parallelogram. Okay, one part is done. Now if we prove that that this angle is equal to 90, then we are done. Okay, so for that, what we can do? Okay, so for that thing, we know the angle which is at the center is 90 degree, and these lines are parallel, and this is the transversal. So this 90, then this will be is equal to also 90, and these lines are parallel. So this 90 means this 90. Okay, now we can do this thing. We have AC parallel to SR. Okay, so now we have AC is parallel to PR. So what I can write? I can write that this angle, suppose this point is E, then as diagonals are perpendicular to each other, so that will be also 90. So angle SAQ is equal to 90 degree, as corresponding angles are equal in case of parallel lines. Okay, now the same thing again. We have SP is parallel to BD. Now SP is parallel to BD. So what we can do, we have SP parallel to BD and SR is transversal. So they are alternate interior angles. So they should be equal. So I can say angle PSE is equal to 90 degree because alternate interior angles are equal. Okay. Now if angle PSE is equal to 90, this one, then I can say angle PSR is also 90 because it's the same. Angle PSR is equal to 90 degree. Okay. Now in the quadrilateral PQRS. Now in PQRS or in parallelogram PQRS, angle PSR is equal to 90 degree. And in a parallelogram, if any angle is 90 degree, we can say the given parallelogram is rectangle. So this thing we have to prove, and we have done this thing, which means angle PQRS is the rectangle. Okay, so that's all for this video. We have two theorems of midpoints in a triangle. So keep practicing this thing, and if you got any doubt, then you can ask me through my profile.